Today we're going to be looking at section 4.09, which is dealing with the fundamental theorem of algebra. And the fundamental theorem of algebra helps us to determine the types of solutions, how many solutions. All right, in our first example, we are given f of negative 4 equals 0. That means when x is negative 4, y is 0. So that forms the ordered pair negative 4, 0. We have f of 5 is equal to 0. That means when x is 5, y is 0. So that's the ordered pair 5, 0. And f of negative 1/2 equals 0 represents the ordered pair 1/2, 0. That means that all of these are x-intercepts, and we know that x-intercepts are also referred to as solutions, roots, and zeros. So if I know that my x-intercepts are the above ordered pairs, I know that x is equal to negative 4. That is a solution. X equals 5 is a solution. And x equals negative 1/2 is a solution. To get the factors of this particular problem, what we're going to do is we're going to work backwards. We are going to make each of these equal 0. So that means I'm going to add 4. And I get x plus 4 is equal to 0. So one of my factors is going to be x plus 4. I do the same thing on the second one. I'm going to subtract 5. And I get x minus 5 is equal to 0. So a second factor is x minus 5. And on the third one, I'm going to add 1/2. And I get x plus 1/2 is equal to 0. We know when factoring that we cannot have fractions. And when we do have fractions, we have to bring that bottom up. So that means my factor becomes 2x plus 1 equal 0. So the factors are x plus 4, x minus 5, and 2x plus 1, which is answer C. All right, let's dive into the fundamental theorem of algebra. The definition is that a polynomial of degree n must have n roots or solutions. What this means is if I have a polynomial equation, y is equal to x, I look at the degree of this particular function is 3, which means that this is going to have 3 roots or solutions. All right, and let me go back because I do not know where I got 3 from. And let's go back to the degree, which is 1, and it has 1 root. All right, so if we have a polynomial function, y is equal to, let's say, x squared plus 2x plus 4. We know that the highest degree is 2. Therefore, this function has 2 roots or 2 solutions. If my polynomial function was y equal x to the 5th plus 2x to the 4th plus x squared plus x plus 4, the largest degree is 5. Therefore, that means it has 5 roots. Now, these roots can be one of 2 types. They can either be imaginary or they can be real. All right, so when we're talking about the roots of a polynomial function, we are going to talk about the real roots And the real roots are the x-intercepts of the graph. And we're going to talk about the imaginary. And to get the imaginary roots, what you're going to do is you are going to take the total and you're going to subtract the number of real. All right, and we'll look at examples of problems similar to that. The conjugate root theorem is very important because it says that if we have an imaginary solution or we have a radical solution, that they are going to come in pairs. So remember, when you have imaginary and radical, you are using the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And because we have this plus or minus, we know that there are two solutions. So if you have a solution, x is equal to 4 plus 2 times the square root of 3, then you also have the solution, x is equal to 4 minus 2 times the square root of 3. It has to be a plus or minus combination. If you have a solution, x is equal to 3 plus 2i, then you also are going to have a solution, 3 minus 2i. Okay? So if we are looking at these particular problems and the roots contain a radical or are imaginary, they are always going to come in pairs. This problem asks, how many real roots and imaginary roots does the following function have? Okay, when I look at the function, I'm going to find the degree of the function. And the degree of this particular function is 3. Okay, so I know that when I take the number of real roots and the number of imaginary roots and I put them together, I should have 3 total. All right, so first thing I'm going to do is I'm going to find my real roots, and my real roots are going to be the x-intercepts. Okay, I have a root at 2. This is x equal 2. Okay, because the graph goes straight through it, I know that it only has a multiplicity of 1. Therefore, I have 1 real root. Imaginary roots we can't see. Okay, therefore, to get the number of imaginary roots, I'm going to take the total roots and I'm going to subtract the number of real. Okay, the total roots, since the degree was 3, means that we are going to have a total roots equal to 3. And we're going to subtract the number of real roots, which is 1, which is going to give us 2. So in this particular graph, we are going to have 1 real root and 2 imaginary roots. All right, the terminology in this one, in bold, it says how many complex roots. Okay, for some reason, when we think of complex roots, we think of imaginary roots. Okay, but that's not the case. Complex roots, when you are asked this question, means that we want all roots. Okay, the total number of roots, which means this is going to be the real roots and the imaginary put together. So how do I find the complex roots? I'm going to find the degree of my polynomial function, and the largest degree is 3. So the degree of this function is 3, which means that I have 3 total roots, which are called complex roots. So when you are asked for the number of complex roots, they want to know the total number of roots, and the total number of roots is the same as the degrees. All right, we have some different graphs. We have a cubic, 2 cubics, and 2 quartic graphs. And it wants us to identify the number of real and imaginary solutions for each polynomial. So the first thing I'm going to do is I'm going to identify my degree. A cubic tells me that my degree is going to be 3. The total number of complex roots is going to be 3. So I'm going to first of all find my real roots, and that means I'm looking for the the x-intercepts of the graph. The x-intercepts, there are 3, therefore there are 3 real roots. And because the graph passes through the x-intercept to the other side, it means that it has a multiplicity of 1. To get your imaginary, you're going to take your total, subtract the number of real, and that means that we have 0 imaginary roots. All right, on the second example, this is a cubic function. The degree is going to be 4. That means my total number of roots is going to be 4. To find the real roots, I'm going to find the x-intercepts. The graph passes through the x-intercept to the other side, so that means that I have 1 real root. The multiplicity is 1. To get the imaginary roots, we are going to and guys, I'm not sure what I'm looking at quartic and putting the answer for cubic. Let's go back. This is a cubic. Degree is 3. The total is 3. So to get the imaginary, we're going to subtract 3 minus 1, which is going to give us 2 imaginary roots. Remember, imaginary roots has to come in pairs. So you're either going to have 2, 4, 6. You're not going to have an odd number of imaginary roots. Okay, number 3 is a quartic. A quartic means that you have degree of 4, and that tells me that the total degree is 4. I find the x-intercepts, and the x-intercepts, I have 2. The line passes through to the other side, each x-intercept, so that means the multiplicity is just 1. So I have 2 x-intercepts with a multiplicity of 1. To get the imaginary, I'm going to subtract from the total the number of real, and that tells me that I have 2 imaginary. All right, the last example, this is a quartic. That means the degree is going to be 4, which means the total number of solutions or roots is 4. Okay, to get my real, I'm going to find my x-intercepts. And on my x-intercepts, I see that the graph bumps the x-axis. When the graph bumps the x-axis, that means we have a multiplicity of 2. So from this graph, that tells me that x equals -1 twice, and it tells me that x is equal to 2 twice. So how many real roots do I have? I have 2, both with multiplicities of 2, so 4 total. And to get the number of imaginary, I'm going to subtract to get 0. All right, our next example, we are going to be given a function, f of x equal x cubed minus 5x squared minus 9x plus 45. We are going to type this into Desmos, so I'm just going to type in y is equal to x to the third power minus 5x squared minus 9x plus 45. And we are asked for the factors, so I have to find my x-intercepts. And I find that my x-intercepts are at x is equal to, the first one is at negative 3. I have x is equal to 3. And I have x is equal to 5. Okay, to find the factors, I have to make each one of these equal 0. So I'm going to add 3. And I get x plus 3 equals 0. Subtract 3. And I get x minus 3 equals 0. And subtract 5. And I get x minus 5 equals 0. Therefore, my factors are going to be x plus 3 times x minus 3 times x minus 5. And the correct answer would have been answer B. All right, on this problem, we are solving f of x is equal to x cubed minus 3x squared minus 3x plus 1. We want to know which are the correct factors based on your solutions. So the first thing that I'm going to do is I am going to type it into Desmos, and I'm going to find my x-intercepts. Okay, so my first x-intercept is at x is equal to negative 1. So to find the factor, I make this equal to 0, and my factor is x plus 1. But guys, look at the other two x-intercepts. We have 0.268, that's a weird decimal, and we have 3.732. If you get a weird looking decimal, then most likely that means that our answers are going to contain radicals. So we have to determine which one of these radicals is equivalent to 0.268. So I am going to type in to Desmos another box, and when I do that, all I'm going to type in is going to be the radical that is shown. So we are going to type in 2 minus the square root of 6. And when I do that, I get negative 0.4498. And that was not one of my decimals. So that radical does not work. I'm now going to type in the second radical, which is 2 minus the square root of 3. And I get 0.267. And look what happens. We have 0.268. That matches. I'm going to type in the parentheses, the second part of the radical, which is going to be 2 plus the square root of 3. And when I do that, I get 3.732. And when I click on that x-intercept, it gives me that same decimal. So my answer in this particular problem should have been answer C. All right, on the last problem, it says to solve. That means that we want to find the solutions, the roots, the zeros, whatever we want to call them. We have y is equal to x cubed. And then it is minus 4x squared minus 9x plus 36. And it wants us to find the solutions. Okay, so I'm going to have to make sure that I can see all of my solutions. And I need to make sure I have it typed in correctly. And when I do this, I find that I have 3 x-intercepts. I find that x crosses at -3. That is an x-intercept. I see that x crosses at +3. And I see that there is an x-intercept of 4. So when it asks for the solutions, all it's wanting me to do is to make sure that I have the problem typed in and I look for the x-intercepts. So my solutions to this problem is going to be -3, 3, and 4. And that would have been answer B.